Hello friends, welcome to our new webinar on integration best practices. Integration is one of the primary showstoppers nowadays, and with varied business applications, enterprises cannot live without it anymore. With newer applications and technologies coming up every day, it is hard for an enterprise to invest time to create data flow for newer applications. Enterprise agility is determined only by how newer and superior applications are being added to the system and how old applications are getting retired easily. By securing benefits of using best of breed applications in the market makes the business processes better and updated. Point-to-point integrations are not a solution as it requires extensive development and testing cycles and also expensive over long run. With cloud being the first class citizen for delivering modern day business applications, organizations are also looking for integration solutions which are cloud first and provides in-depth integration support. iPaaS is one of such kind of concept which focuses only on integration best practices. In this session, I will discuss some of the best practices, not all, so as to how we can help you understand what an iPaaS platform looks like and how industry is building such kind of product. My name is APPSeCONNECT and I am the Vice President of Product in InSync TechFin Solutions, and I am responsible for innovation over iPaaS we are providing called APPSeCONNECT. I have also been a Microsoft MVP and a software innovator at Intel. As per today's discussion, we will primarily focus on integration platform and iPaaS. We will discuss some of the common types of integration, their benefits and use cases. We will primarily focus on integration design guidelines to help you build integration correctly, leveraging best practices and patterns. We will also discuss sync strategies that one needs to follow to deliver good integration between the applications. And we will finally wrap up by giving examples of some of the use cases which we have already catered to using APPSeCONNECT. As per definition of iPaaS, Gartner mentioned it as a suite of cloud services enabling development, execution, and governance of integration flows connecting any combination of on-premise and cloud-based processes, services, applications, and data within individual or across multiple organizations. So the point to consider is iPaaS needs to be a cloud service. First of all, this point removes all the small tools which you may have downloaded for data migration or warehousing. Even though iPaaS can connect to on-premise as well, and there are some products which needs some additional softwares to be installed, yet the basic requirement of an iPaaS is it needs to be a cloud service. Another important point to consider here is that iPaaS is not a software as a service. It should provide a platform which enables development and also needs enough tooling available to support deployment, execution, and maintenance of the software service. And the third point states that it should connect on-premise as well as cloud applications, other services, processes, and even a data source. The multi-tenant platform as a service should work across individuals and the enterprises. Integration is not new. It is there for a long time. A lot of companies leverage small tools for doing data migration and integration. These tools are generally used to map data from one database to another. Data integration is a technique which integrates or migrates one database or files to another database or another system rather. There is another type of integration which is mostly used nowadays is application integration. Applications provide APIs following same logic, how it functions inside the application, and hence it provides an interface to transfer data from one application to another. Gartner suggests API first approach while doing data integration as it helps in delivering data correctly without considering much of the complexities of the application itself. Now, coming to the data integration techniques, it is still there in the market. It is currently used wherever there is no option to choose for an application. Some applications does not provide APIs which needs a direct access to the database to perform operations. Data is basic for every application, and even though an application is have an API, it still have a database or files in it, right? iPaaS provides adapters which can connect to standard protocols. Hence, if the application provides an API, the iPaaS can connect to it easily. But if it does not, it can still connect to the file system, FTP database, ETL libraries, etc. to communicate data from one application to another. Some data integration techniques allows to build applications that goes beyond iPaaS segment. Some common tools or use cases which leads to data processing can also be performed using protocol-based connectivity through an iPaaS platform. Application integration is more precisely API-led integration is one of the recommended integration technique for an iPaaS. If an application provides an API, it is always recommended to use it. Modern day complex business applications provide a lot of functionalities. Some are specifically dealing with the functionality that we use, while some are for user experiences. APIs abstract out these data, removing complexities of the application behind the business logic. Hence, it makes it easier to deal with complex applications. The modern day APIs are intelligent and does not require the end user to know every details. The API are well aware of the background details, makes the usage of it more effective. On the security perspective, opening database and file system to the application is not always good. To access database or file system from the external world, you need to open it from the internet, or even you have to install some small tools on the servers which can proxy the data to the outside world. Hence, security is a concern here. With standard authentication techniques used while accessing APIs, led the data to remain in the secure network and does not have to exposed outside the internet. API-based integration, as it removes the complexity, not only improves security but also reduces complexity, which makes the integration platform to maintain less logic, thereby makes it easier to integrate. The API mostly expose the platform to maintain logic. It will maintain the logic inside the APIs, and you can create your DevOps team who takes care of continuous delivery through the APIs and maintaining the systems. iPaaS provides easier way of deploying integration, and hence any change made on the platform can be easily deployed to the application, thus improving agility of the application as well. And application integration is a technique where the integration consumes API coming from different sets of applications. Some may be ERPs living on premise, some may be custom applications, some may be cloud-based applications like e-commerces. The application integration provides unrestricted sharing of data and business processes among these connected applications. iPaaS connects on-premise, cloud services, SaaS-based applications, PaaS-based applications. PaaS means platform as a service, social networks, IoT, big data, etc. And all of the data coming to the platform can be channelized seamlessly from one application to another through APIs. So in other words, while the data is moving from one place to another through the iPaaS system, the main idea is how the data is getting managed and how the data governed inside the platform such that the automation works perfectly over time. There are a number of features that reports data governance in the platform to easily visualize the problems and easily maintain them properly. As we have understood how application integration works, there is a question that comes to your mind, that why application integration through iPaaS is needed. We could have lived with point-to-point integration too, right? Now the problem is in this era of growing applications, it is not a single application that you are connecting to, right? There are machines, there are systems in place that generate and consume data. Some way or the other, these applications need to be shared among themselves so that they can share data between themselves. This creates integration requirement, right? If we go to the traditional way of integration, each service is individually connected to another, and which becomes unmaintainable over time. iPaaS provides a centralized hub which allows to manage and govern how the data will flow from one application to another using standard APIs. APPSeCONNECT, for an example, is an iPaaS that governs how the data can freely flow from say your POS system to CRM to marketplace to e-commerce application to shipping application in cloud or also on-premise ERPs, which are hidden behind your company firewalls, etc. It provides a set of services that can fetch data from these systems and proxy them to desired location configured in the platform. The data flowing from these applications enables business process automation. Some of the examples of business processes which it automates are listed here. You can see it can automate B2B, B2C orders, leads, opportunities, warehouses, legacy systems, ERPs, procurements, customer care, etc. So there are a lot of, the list is endless. These processes can be connected using APIs, and data can be automatically processed and pushed to the other applications through iPaaS. Now, as we know, integration is critical for any business. It would be nice for us, being from the developer perspective, to understand how we should do the integration, right? I'll give you some of the basic design guidelines and best practices which, as an implementation member, you should follow and to improve your overall integration quality. So coming from software development, it is most common traits to discover the principles of best application design. Here are some of the criteria which talks how you should develop the integration to ensure scalability, maintainability over long run. The first point talks about application coupling. We should consider decoupling of application when defining integration, such that the applications can individually evolve without causing problems for others in the same integration process. Tightly coupled applications makes assumptions on how other application will work, and when the application changes the behavior, the integration breaks. We need to minimize these assumptions and make it loosely coupled. Simplicity is another important concern. Developing integration for enterprises where a number of applications in action are not finite, it is hard to keep it simple. But the integration specialist, one needs to consider this point such that any alteration is quicker. Integration technology should be unique on the iPaaS platform. With APPSeCONNECT, we generally transform data to XML and then process. Varied number of data formats will increase the amount of complexity that the application layer needs to bear. Timeliness of data delivery is another important consideration which, as a citizen integrator, one needs to take care of. The integration should minimize the length of time between the data creation and the data transfer, such that critical data could be transferred quickly in the platform. Asynchronicity: typically computer processing is synchronous, such that during the processing of one integration, the other processes are kept on hold in queue, such that when the process finishes, the other process will invoke automatically. Asynchronicity will ensure that the critical data does not need to wait till the other data is getting processed. The best of breed integration platform makes sure all processes are running in separate thread and all can work parallelly. Some applications does not only share data, some share functionalities as well. In such scenarios, the integration platform could invoke certain functionalities on the other applications during integration. An integration platform always breaks individual instructions into data packets, even though some packets could have some instructions in it. These packets flows freely between applications, and they are called messages. Now, why messaging? Messages are the unit of data block which is fetched from one end of the application or even a data source, transformed to some other messages, and then consumed by another application. This is a unique way of communicating data or instructions through iPaaS. We do messaging to ensure the data or instructions are totally decoupled and from the application, and instructions are and messages are in standard format, understandable by the platform. For example, if we think of JVM, the Java Virtual Machine, the Java code is compiled to something called bytecode, which is only understandable by the JVM. This reduces complexity of JVM by nth time and also enables JVM to be cross-platform. Similarly, here the messages are cross-platform, and integration platform can handle any application on any technology easily through the help of standard messaging. A message channel is a service where messages seamlessly flow from one end of the application to another. The messages are written over a message channel such that any other application can consume it easily. Sometimes message channel is backed by storage, which ensures delayed guaranteed delivery of messages as well. As messages come along in a pipeline, we process them in message channel using nodes that specifically follows a certain pattern. Here is one of them. It is evident that a message can hold multiple records. The splitter is a pattern which splits the batch of records in a message body into smaller chunks of multiple messages. It ideally separates all records into one record per message block, but certain integration provider also allows you to make smaller batches of using splitters. One of the splitter once the splitter splits the messages, the individual messages needs to be processed using a loop. A splitter node requires an entity path to split the record. Once the message is split, it can individually be identified and processed. That's why after a message is split, you can work with decisions or routing very easily. Aggregator is on the other hand just an opposite of splitter. Splitter splits the messages while aggregator pattern ensures that messages are merged into a batch. The aggregator receives a number of messages and punches them into a single message block such that it can be consumed as a batch by the application. The next pattern that we will be looking at is a filter. Sometimes during processing over a pipeline, we want to discard some of the unnecessary entries into a dead letter queue, or we want to discard it permanently. Message filter allows the channel to filter out unnecessary information out of the packet and thus remove the overhead of maintaining unnecessary data. In the above diagram, you can see the gadget code does not require attention in the integration and hence been removed from the message block using a filter node. As an example, let us suppose a channel is producing orders from e-commerce application, but there is a logic to identify whether the order is producing orders of zero value or not, and the requirement from the customer is to remove all the zero valued orders and push only the orders which have a positive value. Now if your API does not support such filters to filter out all the zero valued order, you might want to use the filter node to discard all the orders of zero value before pushing it to the application. And the filter node also works in batch. That you need to consider as well. Another important pattern is content-based router. As we have seen, the splitter which splits the batch of record, a content-based router enables to route the messages based on a special content. As per previous example, let us suppose you want to process zero valued order in a separately while you want to process other orders normally. In such a case, the content-based router will help you determine the routing rules for these special type of messages. Now, in case of mission critical data, we might want to create producer consumer model where the sender sends the messages into a common source of resource which is available with iPaaS, preferably an service bus implementation, and there are a number of consumers which compete between one another to process the messages. A competing consumer is helpful when there is a need of faster processing of messages in the integration platform. For example, let us suppose you are in a POS queue and you want the orders to be processed very quickly such that you can generate invoices. In such a case, competing consumers will help to process the orders in almost real time. A guaranteed delivery model, on the other hand, is just an opposite of competing consumers. In this case of guaranteed delivery, the messages are pushed into a storage such that the storage is faced by the receiver for processing. In such a case, the messages are backed by a persistent storage which enables or ensures that if the consumer or receivers are not available, still the data will be safe in the storage, and as and when the agent activates, the disk is read to process the remaining messages. Invalid message aggregator is a special message queue that aggregates the invalid messages from filter or erroneous data coming from the message channel to separate channel for invalid message processing. The invalid message aggregator is useful to auto-process or retry the failed items in the platform. Sometimes the requirement of an integration is maybe real time. In such a case, the user wants to push the data directly from the application to the integration platform. In such scenarios, we need a request reply processing. In case of request reply processing, a webhook is configured in the application end to invoke specific integration point. When data is put on the application, the data is triggered over a particular channel through a webhook, and the request is getting processed by the messaging channel. The request channel is provided with a request message and sent for processing for the reply channel to respond the messages that needs to be pulled from the integration platform as a response. The process requires a web server that acts as a service from the integration platform. As I've shown you 10 of the messaging patterns here, there are many more to discuss. We will discuss others in a separate webinar, which we'll schedule later on. Now let us talk about some of the string strategies that we need to follow while developing an integration. An integration developer in an iPaaS, there are a number of sync strategies that can help in building correct integration. Some of them are good, while some are okay. Let us take a look at some of the logics which you need to build up while developing an integration between applications. There are mainly three types of sync which you have, or rather we have as an iPaaS platform. One way where the data flows from application A to application B. Application A pulls the data and pushes it to application B. Two-way where the data flows from application A to application B and vice versa. Both application A and B pulls the data and pushes to another to each other rather. And the third one is the real time, where the integration provider acts as a mediator and both application pushes data to the integration platform for processing. Based on customer requirement, one can either choose one way, two way, or real time. Generally, people choose one way sync only to avoid complexities on the integration platform. Now, let us talk about some of the strategies that are followed to sync data one way. Extract by flag. Here, the data is fetched based on a particular flag. The flag is stored inside the application using user-defined fields, such that during processing, the data which are processed will be updated as true. For next iteration, the integration platform only fetches the data where the flag is false. In this scenario, the integration platform can uniquely identify which data is correctly processed and which are not, and as the data is stored within the record itself, when there is an update on the record, the flag can be reset again easily. This is regarded as the best case scenario, and this strategy should be used if there is an option. Now the second one, extract by last updated date, will get records from a particular date time reference maintained or stored in an integration platform. Once the data is fetched from the application, the maximum date from the record packet is updated into a persistent storage in the integration platform. The storage is used to subsequent requests, in which we use these date time as a filter criteria. This type of sync strategy works good as it fetches time from the records. It is the second alternative for one-way sync and should be used if flag-based approach is not available as an option. Now, the third, in case you don't have an option to fetch data even using date time, you might capture the data into the integration platform to filter out the updated entries. The change data capture will require to store the mapping information into the integration persistent storage, and once the data is fetched, it validates the data from the stored tables to identify newer additions. This type of approach is time consuming and requires additional overhead of the integration platform to back up and store transactional data. This is only useful when the first two strategies does not work out for a particular integration. For two-way sync, the requirement is much more complex. Here, the data once moved from to the other application can also be fetched back in, as there might be another integration that works in the opposite. Here, both source and destination application updates data, and newer data is present in both the platforms. Let us look at the strategies that you might look at that can help in building the integration. In the first strategy, we fetch all the records that are modified or updated by users other than a fixed user. So we will have to identify a fixed user, which we term as an integration user, and update the data to the other end using the same user. So whenever the integration updates the data to the other end of the application, it will mark an update from a particular user only. Hence, when the integration executes a sync operation, the data gets always updated by a particular user, and we filter out the data based on that user. So we filter out all the records which are not updated by that particular user. that is the integration user. This is the best approach as it is mostly feasible to create a fixed integration user, and it works best for two-way sync. If the first approach is not available, we can make use of the application triggers as well. Some applications allows you to create triggers which will let update a flag for a particular user, such that when the data is updated in the application from the integration user, the flag gets updated to true, and when others change it, it again changes to false. In both the applications, we filter out data which are false and integrate them. We update both the records in both the applications to true after the sync process gets over. Sometimes both the first and second approach is not available, but you still need to do a two-way sync. In such scenarios, you need manual conflict management. In this case, the data from one application is checked in the second application. If it exists in the second application, it is fetched again from the second application itself. The integration platform merges the data either by taking one as a master and another as slave, such that when there is an update of the same data in both the places, the master gets priority, or it create conflict bucket when there is a change in both the places. Once data is merged, the data is updated in both the application, or a separate storage unit is used to show the conflicts such that the end user can resolve it manually. In case of real-time sync, the data is pushed into the application. The platform generates a web host listener and gives an URL which can be configured for pushing data to the integration platform itself. In case of real-time synchronization, we also have two strategies in place. Depending on the user preference, we can make use of any of these patterns. First one is the synchronous pattern. In such a case, the request is received and it will wait for generating the return packet. The request will return only when the data is either successfully synced or failed. Proper messaging can be performed through the integration platform, or rather can be sent back from the integration platform, indicating whether the integration has successfully synced or not. Now, in certain cases, it is not required to return status. This is often required when there is a huge time required to execute an integration process. In such a case, asynchronous pattern is preferred. In case of such scenarios, the fire and forget technique is chosen. In this scenario, a correlation ID is generated for that particular request, and the response is returned back immediately. The process works in background, and one can re-request to a particular endpoint using the correlation ID to get the actual status of the process after certain time is elapsed. As this will require two requests and require to store correlation ID and have additional overhead, first approach is preferred. Building an integration without customers use case would not work. Let us now consider a few use cases where APPSeCONNECT uses based of the breed patterns like mentioned in this session to improve performance of the connectors. The first customer is Nine Line Apparel. They are a very big brand in US. They are using SAP B1 with HANA as ERP and Shopify BigCommerce as e-commerce store in multiple geographical locations. They use Zoho CRM and ShipStation for shipping solutions. They required a solution of data synchronization such that all data is updated correctly in the systems without manual intervention, as everyone requires. It required a two-way synchronization from Shopify to BigCommerce, which we have implemented through APPSeCONNECT using the two-way sync strategy. And all the data coming from either the e-commerce is synced back to the ERP. The ERP is then triggering the data to ShipStation and Zoho for further processing. There are few challenges in terms of coupon code on how the coupons are applied on the e-commerce sites, and all these challenges are addressed by our citizen integrators. Another use case which I want to mention is one of our customer called Shop@Showcase. They are another customer having stores around Canada. They are extensively using Shopify and need seamless integration between Shopify and SAP V1 with Salesforce Marketing Cloud. They use one of the sync strategy that we have mentioned is the real-time integration, which pushes the inventories to our platform from multiple warehouses, and the data is eventually processed back to the ERP systems. So they use the real-time scenarios where we host the application as a web server, and the external application through webhook pushes the data to our platform. So Shopify is configured using the webhook, and a special URL that is generated by the platform is configured there, and any data which is put into the system of Shopify will automatically trigger the webhook, and the data is being updated in the ERP systems. Now, finally, as an iPaaS provider, I would like to address some of the major benefits of using an iPaaS platform. Here are some of the listed benefits that I have identified for you. The iPaaS, being a cloud service, provides scalability. Each individual tenant is highly scalable, and based on the usage, it can allocate resources. If not using cloud hosted model, the iPaaS provides local agent clustering, which stimulates edge computing. A tenant can increase and load balance agent clusters to scale up resources. Unlike phrase development, iPaaS provides pre-packaged templates which can be used to plug and play ready-made integrations with major tenant specific changes, or rather small tenant specific changes, which reduces the overall implementation timeline considerably. iPaaS services are easier to maintain. It provides advanced tools that enable quicker bug identification and rectification, automation testings on integrations, reportings, etc., which helps easier maintenance of an integration in its entire life cycle. The iPaaS, being a cloud offering, also reduces the cost of ownership, as user can easily be added and removed from the system without requiring much of hand holding. And it gives you an option to manage users of your organization easily. Thus, it reduces the cost of ownership. And finally, rapid time to value. Similar to many cloud platforms, iPaaS also provides rapid time to value. You invest lesser and lesser time to get good amount of value out of the system. Hence, the bottom line is the competitive edge. As you save more money, you will get more profit out of the same business. So these are some of the benefits that you might be getting by using iPaaS rather than the point-to-point integration systems. So that's all. We are now open for questions. If you have any questions, you can ask or type in the Q&A panel. You can connect us in these social media links if you want. There is an email given as well. The LinkedIn, there is a Twitter handle, and Facebook and Instagram. We would request you to follow them. So if you have any questions, you can ask me. Thank you for listening to us. We are open for questions. If you have any question, you can ask me about integration patterns and services. I hope you liked the session, and hope you will get most out of it. Thank you. So we have a question: which iPaaS platform are best for mid-sized company? So basically, it depends on how extensive you want to use. For mid-sized companies, I would recommend the platform where you have an option for pre-packaged templates, where you have to invest less time, and you can get more value out of the systems. You might go for it. For instance, let's say I want an integration between SAP and Magento, where I get orders from the Magento store, and I want it to be processed very quickly. So prepackaged templates will help you to identify the depth of an integration, and you can easily choose an iPaaS platform like this. Now there are more questions. Let me. My client have SAP Business One SQL. Okay, so in case of SAP Business One SQL Server, you can still connect to multiple other applications. So the question is not clear to me much. Okay, the third one. Okay, so these questions are coming from the same person. So he wants to implement Magento store on cloud, and he wants to implement SAP Magento connectivity probably. So what you can do, you can connect to us. So we will connect to you, or you can connect to our sales team. So they can guide you how to integrate between SAP and Magento. We have an in-depth connectivity between these two systems, so you can try out our integration as well. Otherwise, you would be most suitable if you go for prepackaged templates where you have these kind of systems ready. Now, Jai Kumar has asked what is the right team size and roles for a mid-sized company to begin the iPaaS journey. So, if you are starting an iPaaS journey, so you mean to build an iPaaS from scratch. In that case, probably you need expertise on multiple systems. You need to understand how you can integrate between applications. You have to create your roadmap. So most probably we have a team of 150 developers who work in our iPaaS system. For a mid-sized company, if you want to start from scratch, I think from the starting point, from the beginning section, you have to do a lot of plumbing work, and then you will create these kind of platforms. So it takes time, but otherwise I would suggest you can connect to us. We have an ISV offerings as well, where you can use the platform to develop your integration services. So I think that's it. So thanks for being in the session.